Well, hey.
There it goes.
Okay, now we're alive.
Now we're
It's
live.
showtime. It's
So I wasn't
showtime.
live till a moment ago.
No, I know. 1 minute late. Actually, we're
Well,
1 minute late. I see.
I blame entropy. It,
I,
it,
I
it
see.
accelerated.
Someone else on the stream, Stephen M, has adopted the chicken head in 3D for his own YouTube icon, for his YouTube account logo. Do you see that?
No.
It's in the chat. Anyway, welcome everyone.
Yes, welcome.
Thanks for joining us again. I know the last few episodes we've been really flying by the seat of our pants, and they've actually been very good. But if you're wondering why we haven't announced a topic, had a thumbnail, we should probably go back and edit the thumbnails at some point. There's always something interesting to say, though. So if you haven't watched the last few weeks, definitely go back and absorb them, because last week was really cool, wasn't it? What did we talk about again?
Well, if someone wants to send us a summary of the video after we do it, I would gladly put it up on. But after the video's done, I'm kind of exhausted. I don't go back in and edit the description.
No, that's okay. I'll give you the descriptions, Bill. It's all right. They don't have to be super long. In fact, I've noticed YouTube this year changed their user interface to really crush the description down to 2 lines with the ... And psychologically, I feel like that's kind of harsh, because it's forcing users. It might make sense in that the people who are really interested to read it are actually going to expand it. So it's separating sheep from goats, I guess, in a way. But at the same time, it's making it difficult for small creators, or creators with small channels like myself, who have no way of, like my videos on my Schematica channel are not monetized. I'm too small for that.
Right.
And so if I were to try anything, it would be through affiliate links and things like that. And none of them will show up because they're crushed under that little abbreviated top 2 lines. Right. So yeah, they keep moving the goalposts, and it's really frustrating. But anyway, I'll stop complaining about that. I've got bigger fish to fry.
Or they penalize you.
I've got bigger fish to fry today. Yeah. So my Altium just finished updating, Bill. Okay. So I don't know. Before we started streaming, Bill had asked me to open it up so we could talk about something he had a question about. But I actually have another. I said I have bigger fish to fry. Last night, I went to make a surface mount footprint for the Raspberry Pi Pico module. And I shouldn't have to make a footprint for that. So that's complaint number 1. Like, why isn't there a footprint for Cadence, Altium, Mentor, KiCad, whatever the top, let's say 8, the top 8, they should have a footprint for it that you just download from the website. Why are they making hundreds of thousands of people redo the work?
Right.
That doesn't make sense to me. Why do these companies make all of us do the same thing over and over again?
So in what footprint are you after? The Raspberry Pi PC board outline, or what are you after?
Actually, I wanted to make a footprint of the Pi Pico module. So the module can be soldered. Here's a Pi Pico, right? I'm doing a project helping out some friends who I used to work with, and they needed something done really quickly. So they reached out, and I'm giving them a hand as a contractor. But as part of that, like they have a design of a board that's using the RP2040 chip on their own. Come on, focus. This is a Pi Pico.
Right.
Everyone's,
well, which is
most people are familiar with this.
For PCBWay's contest, by the way.
This can, that was one of the other topics for today.
Yeah, we'll talk about that.
We'll get to so this is a typical board, Bob, we call these Bobs, board on board module.
Okay.
For prototyping, or, it's the pin spacing is 0.1 inch on the edges, and spaced between them similar to a 40-pin, pretty much exactly as a 40-pin dip package. So it'll go on a breadboard. So they've designed that well. But there's additional surface mount pads for connecting to USB and some other IOs and test points underneath the board. And there's the debug header connections as well, which are not, they're 0.1 inch space, but they're not spaced like you couldn't use these on a breadboard, right? Because they'd be all shorted out together, or they'd be in that center channel where there's a divider. But the idea is these are so cheap. This whole module is $4.
Okay.
The chip, if you buy the chip on its own, is $1, and if you buy 500 on a complete reel, you get a 20-cent 20% discount, right? So they're 80 cents each if you buy 500. And it's the one decent, powerful microcontroller that's actually available now. So a lot of designs are moving to this. I think, in fact, it makes me even wonder if the Raspberry Pi Foundation is part of the Illuminati and other secretive groups that planned the component shortages.
Oh, I thought Broadcom. I've always suspected Broadcom.
Yeah, it's just fun to hypothesize these things. I'm sure they just got really lucky because of the timing of the release of the RP2040 chip. It's available in spades right now, and it's actually a really powerful little chip. And the fact that they have documented everything very well. So I'm singing their praises right now, but there's one thing that really irritated the heck out of me. And if any of you follow me on Twitter, you would have seen this last night. Twitter @Jordanite is my Twitter handle. You see it there under my thing. I was bitterly complaining about how in some component data sheets, the way they dimension a footprint or the board itself or the chip itself, so that you want it, then you have to make a footprint in CAD so you can design for it. It's forcing people to do. So not only is it, they should have just given us a footprint to download from their website.
Right.
Not only that, and a step model would have been nice too.
Right.
Now I could generate all that from the Cadence files because for this board, they did actually make this open source, unlike the other Raspberry Pis, which are not actually open source. This one is. So you can download the Cadence files, and I can import those into Altium or other tools and, use that. But so they're making us work by not providing a footprint that we could just download. And you can see you could either do a through hole variant where it's like a 40-pin dip and you do it. That's easy. I want access to all the test point pads underneath and have those connected as well. So my footprint's going to be surface mount, and this will actually solder to a board reliably in surface mount, even in production environments as well.
Okay.
So they provide a surface mount footprint drawing, mechanical drawing. Let me bring it up. I'll see if I can. It's in the data sheet. Where did I save this thing?
So I just grabbed it off Snap EDA. Is this the footprint you're talking about?
Yeah, I should have gone to Snap EDA first. That's the one. So someone's already done the work. I should probably just download it from there.
I actually
and then verify it.
I actually used the Snap EDA plugin in Altium. I found it actually useful once I understood where it's putting the parts, and I go get them. So it stores them in a Snap EDA library, and I go manually pull them out of its library because I don't want to be dependent on that library, and I manually add them to my own library then. So I have a little process I do. It's multi-step, but it's what I do.
I'm just opening the data sheet here.
Hey, Vintage, hey.
Pico data sheet, that's the one I want.
Vintage Tech, do you guys allow people to be? We tried to suck somebody into being a guest last week, right out of the chat window when we were talking. So yes, we tried to.
Yeah.
So somebody's asking about Qualcomm being. We do have guests. So go on. So.
Yeah, I've got this on my other screen, so I'll just share my
your screen.
Yeah, share the other screen. Give me 1 second here. So I've got to hand it to them. Like, they've done a lot of work. They've made it really. They've done a lot of work to make really good quality supported product, right?
Right.
But this is, and you can get the design files. Where is it? Mechanical spec, right? This is what I'm complaining about. Let's zoom in on that so I can show you. This is exactly how.
Oh, it's not reference to a datum or anything. It's just like typical measurements.
This is actually not bad. This particular one, which is the module itself.
Right.
They're at least giving you the overall center to center for the side pads. They're giving you the pad to pad spacing, which is 0.1 inch or 2.54 millimeters, right? This is more like how a printed circuit board designer would actually document something, and I'd say that's probably how this was done. This is an image or a fab drawing or an assembly drawing image with dimensioning of the actual board design. This was probably done using the Cadence Allegro product, which I know the Raspberry Pi Foundation are a Cadence EDA shop, so they use OrCAD and Allegro, right? And I know that also because that's the design files. You can download them. They're in OrCAD and Allegro file format. So this would have been done in the ECAD tool. Maybe the next one is too, because the arrow styles are very, very similar. So they at least give us this in this context. But to your point, Bill, where are the datums? Where's the reference? Where's the origin for this drawing? It's probably okay. Probably doesn't matter.
Probably okay.
Probably okay for the actual board dimensions. But if I go to what I'm really looking for is the next one. It's showing on the other side of the board are these surface mount test points. And if you do a surface mount footprint and have the board soldered directly flat down, which it will do happily, without headers, don't need headers. You just have to make sure there's enough solder on these castellated pads, because they have through holes as well. So they're going to suck up some of the solder. So you probably want a slightly larger stencil opening for those, for soldering surface mount. But I want to get access to these test points because they're not just test points, they're actual signals. That, like TP3 and 2 are the USB interface. So if I have some other external USB connector on my board, that's how I'm going to connect to the USB on this board, which you need to do, right? That's how you program it and talk to it from a host. So they explain all that here. Okay, now we go to surface mount footprint and look at figure 5. This is what I was complaining about. I hate this. They do have a reference. Look at that tiny little cross right there. They at least have a reference for that, right? Now, I think they don't explain what it is in this drawing like they should. They just say origin bottom left as indicated. Okay, there's a little cross there, but how is that the origin indicated? If I'm not the person who made this drawing, how do I really know for certain? I don't, because they didn't label it or put a key next to this note up here. I'm assuming that's it. At least some of these dimensions are referenced to that exactly. So for example, these two dimensions is 0.57, which is the edge of the first pad to the origin, and this 0.8, which is the edge of these debug pads to the origin in Y. And then similarly, we have the edge of the pads, surface mount pads, 0.79 from that in X. But here's where I get really mad. This drives me mad. Okay, they've given me pad dimensions up here. That's pretty cool. And they've labeled them, and that just sort of saves space. So A, B, C, D. And okay, now they've given hard XY locations for these surface mount pads for the test point pins. And those hard locations are in millimeters. Of course, it doesn't say anywhere, like a proper engineering drawing should say all dimensions in millimeters unless otherwise stated. Like good data sheets will do that. This is missing clarity, and that's what I'm complaining about. Also, it does not give pad-to-pad center spacing for any of these. It only gives outer dimensions, and it doesn't give gap between them. It gives the extreme edge of this pad to the extreme edge of this pad, then the inner edges.
Right.
And from that, I'm supposed to do the math in my head or on my piece of paper or on whatever to work out what's the width of each of those pads. So the only ones they gave us a dimension for are these small ones in the middle. All of these, you have to work it out by doing the math of the. Now it's just simple averaging.
Right.
It's simple calculations. But think about this. There's probably tens of thousands of people in the world who have to put this footprint in some tool. And each time they're doing that, they're being forced to calculate things. So this kind of drawing to me looks like a perfect example of how not to do it. You're making your customers do tons of extra mental work. Those brain cells and that willpower is a limited resource, remember. We need that for other parts of our design process. We need that for figuring out much more important things, like how many clock cycles am I actually going to have between interrupts if I set this timer to this frequency, and therefore, what's my interrupt latency? How many cycles do I have? And can I put this whole thing into an interrupt routine, or do I have to set a flag and do it in a foreground process?
Right.
You know what I'm saying? That's what we need our willpower and our brains for. We don't need it for this kind of BS. Drives me mad.
Right.
So kudos for a great product, but please improve the documentation, people.
Right.
Anyway, so that's what it's like this. And for anyone else out there, there's a lot of people who watch our streams after the fact or live. We've got 48 on right now. Thanks for joining us. A lot of you are designing circuit boards and designing footprints and things. I know you would be frustrated at this too. You'd be thinking, why do I have to do all this extra work? Yes. Okay. Now, Bill, you immediately went where I wasn't thinking last night and should have gone to Snap EDA because I am familiar with them. I started building this footprint, and then it made me realize I'm also frustrated with the ECAD tools because almost all ECAD tools don't allow you to place things easily using calculation fields.
Right.
This is something that Altium customers have been asking for many years. Hey, any numerical field anywhere in the tool should be a calculator. You should be able to go in there and type in an expression and even reference other parameters and have it just work it out. Because I'll tell you what, mechanical CAD software has been parametrically driven like that for decades. And the first ECAD or PCB tool I ever saw that had this capability was actually, believe it or not, Upverter.
Okay.
I don't know if anyone remembers Upverter. Upverter was a web browser-based, cloud computing-based PCB, schematic and PCB tool. Was developed by a group of engineers in Canada who are buddies of mine because Altium acquired Upverter. And I was working with them for a time. So, hey, Zach, hope you see this. Zach Homuth. And there were like three main guys that built it, and they had a team. And they actually why do no EDA tools have this calculation capability? And they actually built it, architected the whole system from the ground up to be parametric. So it was actually quite advanced. It, being browser-based and everything and fully cloud, of course, it had its other limitations, and that's probably why it never really took off. So Altium acquired them and got that technology, but just took the brand and killed the product. The brand is now something different that's modular design and design automation at the modular level. So I'm going on and on. So I hope this is actually interesting. So Upverter, as it was with the parametric dimensioning of PCBs and footprints, that is no more. So don't go looking for it. That's why I'm saying all of that.
Right.
Altium basically killed it. But yeah, I'm like, EDA companies, you need to make any numerical field within your tool, make it an expression, build it, redo them so they can accept expressions and at least calculate to a hard number.
Right.
And don't have to remember the expression. You know, Fusion does this. Fusion is awesome.
Right.
All mechanical CAD tools can do this. And so I could probably give you an example of what I'm talking about. I'll just need to open a design to do it. Or I'll start a new design. Let me share my other screen. Oh gosh, I keep losing you.
So my personal preference would be, if I did grab one from Snap EDA, obviously you need to go in and check it yourself and sanity check.
Yes, you. That's it. And seasoned, you know, graybeard PCB design wizards always tell me, I never use footprints done by someone else, unless they work for a big group in a company and they have a designated set of designated librarian who does it all, and they submit a request and they generate the footprint and tell them when it's ready. But outside of that situation, every seasoned PCB designer I've met has said, oh, I don't use footprints downloaded off the internet, which is not really true. I think what they really mean is
the important ones.
I'll download it, but I'm going to make for darn sure it's accurate and build it myself from scratch. Otherwise, you know,
I do lots of PC boards where I get 100% of the footprints offline, just 100%. I get it out of the tool, built into Altium through the manufacturer part search. But again, I'm responsible for those footprints, but I have no problem starting from a source. And if I need to modify one, I'd rather modify one that's got all the layers already present than making one from scratch. I'm just not good enough to make it from scratch. Well, shouldn't say good enough. I'm not practiced enough to do it tomorrow without thinking.
Sometimes it's faster just to redo it from scratch if you particularly don't like the style or don't agree with how it was done.
I often
still do them from scratch, even if they're downloadable. But where possible, hey, that's funny. Fusion just crashed when I moved it from one monitor to the other.
Oh wow, it's probably a GPU related thing, right?
It could be.
So Dave Adams says, as long as it's not an Altium footprint, what's wrong with Altium footprints? Each footprint's different. It's like children.
I got news for you, Dave, and this is a bit sad. Altium actually did make footprints with a very large library team.
They did. Yeah.
And the leader of that library team for more than 10 years was a friend of mine named Roland Washington, who is just a genius. He's from Hobart, Tasmania. He's not at Altium anymore. He left some time ago.
Tasmania.
Before I left, actually. But they were the only EDA ISO 9001 quality assured librarian team for any of the big EDA companies for a long time. And the funny thing was, yes, and I know why you're saying that, Dave, because there have been one or two footprints that were bad, that had incorrect pin assignments, or they had a differential pair swapped on something. I've seen that a couple of times. They used a lot of automation in what they did. They built a lot of scripts and things. They had a lot of very clever tools that even other people inside of Altium didn't know about. And the reason for that was the way that they were able to get so many parts done. They actually, by now, have made probably over 1 million footprints and symbols. And
wow.
here's the funny thing. They ended up partnering with semiconductor companies to make full libraries for the semiconductor companies, not just for their own internal use for applications engineers doing reference designs and app notes, but also their whole product catalogs, right? So when they would introduce a new chip to the market, they'd want footprints and symbols made for it. And some of these companies partnered with Altium because of the ability to make them for them. So, and others would have their own in-house people make them and then donate them to Altium, so Altium could vet them and then share them with Altium's customers.
Right.
But there were always in any database, in any library where you have literally 500,000 components. By now they're at probably 700,000 or so. And most of those follow IPC standards for least nominal and maximum courtyard area as well, or density. And so you multiply that out by the number of footprints. You have literally millions of CAD models.
Right.
And all of them are correct according to manufacturer data sheets, but occasionally there is a mistake. And I've known customers who've found those mistakes. I think Dave, you may have found some of them as well, or one or two. And the mistakes, there may be one in several 100,000. But one person knows about it. They share it. It goes on the forum. Everyone knows about it, right? So it appears like that. And I'm not saying this to defend them or anything, but I think they did a pretty darn good job, all things considered. But still, most customers wouldn't admit to using them. They'd say, "Oh, I always make my own."
Yeah.
Well, I think mainly they would use them, but they would take the time to check them for accuracy.
Right.
It is on you as a designer that you do that, of course.
Right.
But here's the interesting story. Altium made all those footprints, and in partnering with some of these big semiconductor companies, not mentioning any names, right? But those semiconductor companies would then receive all this library content that Altium did and share it and translate it into other formats for their other customers.
Right.
And the next thing you know, we have companies like SnapEDA and Ultra Librarian. Guess what? They suddenly have 500,000 footprints. Where did they get them? I know where they got them. I can't prove it on a little discussion like this, but I can trace the source. And they've made a lot themselves. The thing about SnapEDA that's interesting to me is it started out pretty much crowdsourced. So anyone can contribute a footprint. Yeah,
hey, Ben, I have to go.
Oh, no, really?
I do. So I will talk to you later, and you can continue the good work, and we'll talk about PCBWay next time. Unfortunately, I've got a network emergency.
Bummer.
I apologize.
Bummer. Okay.
So I'll talk to you later.
See you, Bill. See ya next time. Okay. Anyway, I've gone on for long enough, probably, but Electron Ash, you were just saying, smaller protos, just do some basic checks and send it off. Yeah, when there's not a lot of skin in the game, it's you calculate what's my time worth versus the risk, right? And then you narrow it down. If you're going to production, obviously you you need something significant, better quality. Something might work fine for hand soldering, but not for production assembly. And it could just be some small part of the footprint that's causing that difference. So yeah, it's so that was the frustrating thing. What I wanted to show was the difference then in and my Fusion crashed, which is really irritating. I wonder if I can show it in. I'll go to a Libre since it doesn't crash. So I'm just opening up a Libre here, and once it's on my other screen, I'll share the screen and show you what I mean by this whole parametric design thing. This was an interesting comment too. If you could make a PCB with lots of bridge rectifiers and parts to convert the potential difference between earth and ground for power. I'm not really sure what you're asking there. I thought that was going to be a different comment, more to do with if you had, because something you can do is extract footprints and symbols from existing designs. And I'm pretty sure most ECAD tools, I think KiCad has scripts for this as well. So if you have footprints you need and you know they're on some other design, you can get them off of it. You can basically add them to your own library. And that's a good way to get them, because if it's something that's open source but it's gone into mass production, like the RP2040 and the Raspberry Pi Pico, whatever they've used on that board has been mass produced, so you know it's good for that. Everything wants to update today. What the heck? Okay, I'm going to say remind me tomorrow, and I'll share my screen again just so I can explain what I'm going on about with this whole parametric design thing, right? So there's the data sheet, right? I'll keep that handy, and I'm going to let's just make a generic part. It's a little tardy. Oh, open on my other monitor. There we go. Let's just move that over here. So this is one of the two ECAD tools that I love, MCAD tools I love to use. I've used a Libre for many years, and because I previously worked at Autodesk, I got very familiar with Fusion, and Fusion has some awesome things that a Libre doesn't have, and a Libre came with some awesome things that Fusion doesn't have. So I kind of keep them both. But this is what I'm talking about. I'm going to start a mechanical part drawing, a sketch on the XY plane, right? And if I want to make, let's say I'm going to make something, and I'll start a circle here. In every MCAD tool under the sun, this is a kind of a standard way of operating. You start with a 2D sketch, and then you're going to extrude things and draw from that. And everything is dimensioned at the basic level, like the architecture of the whole thing. I don't have to just randomly click that and then go edit the properties of the object like ECAD tools tend to do, which is frustrating as heck. It should give me the option of just typing in a number. So here, it does do that. You've got the main dimension, which is the diameter. And let's say I'm going to make that 40 millimeters, dual coordinate system, right? And I'm going to do an outer ring on that. And I'm going to make, and now here's the thing. I could be referencing another dimension or parameter. So if I hit escape and go into the equation editor here, I can add global parameters, and I can bring them in from a file. So I can design a whole thing and reference parameter names, and then import files to automate the actual sizes of everything. If I go into the equation editor, this lets me do things as well. And I can see the first diameter that I added in here. Let me expand that out. right? It's showing in inches because in the Libre I set my default units to inches. But that's I think I said it was 40 millimeters, right? 1.575 inches. That's called D1. So anything that I add manually is automatically retained, and I can reference it as well. So let's say I want another concentric circle, and that circle has to be, you know, it's going to be D1. So I can type this in directly. And let's say I want to make this twice the other dimension. It's going to be double the diameter. So I can just type in a regular expression and it does it exact. And 3.15 inches is exactly twice 1.575. Right. So this is what we mean when we say parametric modeling. And this goes not just in the 2D sketching, but into the 3D as well. And you can predefine parameters. As I said, you can import them from a file. Fusion 360 can do this. Any mechanical CAD tool can do this. And this is a massive advantage. And this is what I'm putting out a call to the EDA companies, to Altium, to I think Autodesk with Fusion 360 with the ECAD side that came from Eagle, they've actually started enabling expressions like this in the PCB editor as well. It's been a month or two since I've done any PCB design work in Fusion, so I'm a bit rusty on that right now. But like, this is what we need, people, because then it doesn't matter how someone lazily dimensions a data sheet like what we saw here. We can use whatever they give us because it's all relative. It's all relative. And we can enter these dimensions in a parameter table, and then we can define every object we place and its location, and it can be automated a lot more. So anyway, looks like what I'm going to do is just download from SnapEDA. Let's actually try that real quick. If I go to, I'm on the other screen there. 1 second. Oh, I had so much I wanted to talk to Bill about. It's a bummer he had to leave. I was even going to talk about one of my favorite artists of all time, Roger Dean. But totally off topic, so I'll do that some other time. But we're going to go to SnapEDA. And actually, I should see if Octopart has this as well, because they probably do. Oh, the wrong key there. Okay, who's likely to have a footprint for this? I'm not sure. If a footprint were available, there'd be links right about here to show that, but I'm not seeing it. So okay, and this is cool. So we have datasheet, symbol, footprint, 3D model. I like that because I do want a 3D model for this as well. And simulation, of course, you're not going to have that for something like this. But the question is, are they the surface mount footprints or the through-hole version? Because I want surface mount. Let's have a look. That is completely the wrong footprint. That's the footprint for the RP2040 chip itself, the QFN. What have we got here? Same thing. That's just the QFN. It's not the module. So this is the problem when you get these crowdsourced things like this. You get a lot of junk and you've got to waste time sifting through it all. Let's try this one, SC0915. Yes, and that's the surface mount footprint I wanted because it also has the pads for the test points for connecting to USB and the additional IOs. So this looks like it could be exactly what I want. Let's see what the 3D model looks like. Oh, it's nice. It's an actual 3D model of the board design too. Very cool. So Snap EDA, this is great. Oh, and I think the reason why this one is accurate is because it's not a crowdsourced one. It's been created by them with their own in-house engineers. So let's see. They say it's been passed for manufacturability, accuracy in the documentation, schematic, etc. I don't know how they actually achieve that verification. If customers use it for production and come back and say yes. But this looks like exactly what I want. And this is nice too. Look at all those different file formats, even KiCad. Perfect. Let's go. Come on. Thank you, Natasha and Snap EDA. I guess I'm already a user, so I should just sign in. And let's go. I'll get this in Altium. I'll just put it in Dropbox. I have a components. And let's see, app notes, data sheets, models. Here we go. Footprints. I'll go in the main footprints folder there. Let's go. I should have just clicked this. I didn't read this. It says download symbol and footprint. Let's do this. I'll override that one. Okay, and I also want the 3D model. I'll probably have to attach that separately. Though I know Snap EDA were actually working on a format using native formats, but like many other companies doing this kind of content, they could never get the documentation they needed to make it happen easily. So where's my Altium Designer? Let's move that over here. And the reason I wanted this was I was going to design my own little arcade board that has an RP2040 Pico module on it. So let's just go. Let's just do a file open here. And that's in my get rid of the filter there. I don't want projects and documents. I want, there should be a filter for all files here. Let's just extract that. SC0915, and in here, it's an integrated library. So how about that? That's footprint and symbol together. Now, if I open that in Altium Designer, it should ask me, do you want to actually import this into the workspace, like add the library, or do I want to extract the sources to edit them or install the library? What I want to do is import this into my workspace because that's how I manage all my parts now. So it's actually going to translate that integrated library. I get all sorts of flags from Altium all the time. There we go. It's because it's always trying to communicate with the cloud. Of course, I'm wanting it to right now because that's how I manage my parts, as I mentioned. Okay, so we have a footprint and a symbol. think I want to rename this. So it's Raspberry Pi Pico. And the footprint, I'm going to do the same thing. SMD or SMT. It's going to be surface mounted to the board. I'll add some description here too. P2040 USB debug module SMT version 1 because it's the first Raspberry Pi module they released. And let's see for symbol, what have I got? It's already got a description that looks pretty good to me, so I'm going to go ahead and validate that. I think we're okay to go. This should be, oh, wait, I'm missing a component here. So what do we have? It wants to bring in the symbol and the footprint, but not the overall component. I think that's okay. I'll build the component afterwards. So the reason I'm jumping through all these hoops here is because I manage all my parts together in a formally released cloud storage container that I have as a user, but I wouldn't have to do that. I could just use the integrated library on its own, working locally as well, and place the parts into designs straight from there. So there's different ways to do it. I could keep it way simpler, but this is just how I like to manage things. Okay, so now in my components panel here, what I actually want to do is create a new component, and I'm going to put it under integrated circuits. Or do I have a modules folder? I forgot how do I organize this? I'll just put it into processors. I don't need that panel now. So Electron Ash, you were saying some time ago, Circuit Maker forced you to be open. Yeah, because it was a free tool. I was the product manager for that. The executive team and the VPs of R&D insisted that if we're giving something away for free, there has to be some limitation, and that's why. I wasn't really for it, but Circuit Maker is a bit different now. You can have way more designs. I think they may have lifted the lid on that limitation. They are all still cloud stored, but until you share them, other people don't see them. So it's taken that interesting turn. And the only other limitations is it was slowed down and doesn't have all the same features. So it's more like what people were asking for to begin with, from what I can tell. So yeah. Dave, yeah, don't place your designs in the cloud if you're a security company. I totally get that. It's not for everyone, and there'll always be tools for people who don't want to do that. That's fair enough. Yeah. So I'm going to place an existing symbol in this component. I'll just search for it here. It'll be faster. There it is. There's the symbol. Not sure I'm a big fan of that symbol. I'd probably go ahead and modify that later, but it's okay for now. Add an existing footprint. No, I don't want to use the wizard. Let's go existing. Now, this will be interesting if the SnapEDA footprint already had the 3D model associated with it. It probably didn't, in which case I'll attach that. And it looks like it doesn't. If I go to 3D mode, I'm only seeing the surface mount pads, right? So they've created an accurate footprint. I do note that there's no solder mask opening for the pads for the test points. So that's not accurate, and I'm probably going to have to fix it. Okay, so let's call this T. RP2040 module SMT, including test points. Okay. While I'm at it, I might as well add supply chain data. I'll clear that because that's not going to get any hits. Let's go for, it's not a compute module. It's why these search results aren't really very good. Let's try it a different way. Pico RP2040. Well, that's the one that we found that's in stock as well. So these are all, what's Pico H? It's not a Pico wireless. And the Adafruit ADA4864 is the same one. I know that for a fact. This is the same one, but it just comes with some headers in the bag. The rest, I think, are wireless variants on those, so I'm going to leave those out. But that adds parameters to the part through search. Let's go. Yeah, I'll use, I don't want only matching. I want all the parameters. Seriously, that's all there is? Huh, okay. So it didn't add any useful parameters. I can go and do that later. Now I want to edit this footprint to make sure it's accurate. Okay, so maybe the preview has a bug because I am seeing solder mask openings there. That's what that purple outline is, because that's the top solder mask layer. Let's see, top paste. There is solder paste on them as well. So actually, this footprint does look good. One thing I really must do, and just to not use up, because I'm almost at an hour of streaming now. They got these wrong. These A, B, C's, and D's, I'm pretty sure are not. Actually, maybe they are. Let's go back to that data sheet real quick, because I'm not sure if. I think those are only labels for these pads to give the pad radiuses and things, right? I could be wrong. Those are pads. Those are pads on the main board. So yeah, those do need to be there. Okay, good. So again, I'm wrong. SnapEDA was right. That's a good thing. Those pads are meant to be there. That's the shield of the USB connector, and that'll give it more mechanical strength if I were to use this on the back of an enclosure or something. So the one thing that is missing here is the 3D model. Let me do something else here. What I like to do is standardize all my layers. And so I'm going to import layer sets. Where did I put those? It's been a while since I did this. They should also be in my components folder, or models perhaps. Maybe not. Okay. Where would they be? Where would they be? Because I want to reuse layer sets and standardize everything to use the same template, same layer names, same configuration. I just have to think, where did I put these? They're here somewhere. Cool projects, blah, blah, blah. Projects, maybe they're in here. Design, reuse, panel test. I could use Windows search. Let's try this. Dot layer star. It's dot layer set. Let me be more specific in my search. I want to do star dot layer set. I wish I could remember where I put things. Sorry, folks, for all the Slack interruptions with another group I'm in there. Okay, maybe there. Maybe, just maybe. I'm about to give up on this quest to find my layer sets files. Because I know it's riveting watching me like the blind leading the blind, rummaging for things. I really need to be more organized. I'm pretty sure they should be somewhere here in this Dropbox folder. Let me do a filterless explore on this, because I know they're here somewhere. I may have used a different file format name. Templates. These are stack up. I called them .stackup files. That's why. That's why. Okay, that's why. Now I remember. So I'm not going to do the layer set. I'm going to do tools, import mechanical layers. There's two ways of doing this here. And there it is, component layer pairs. Okay. Now let's see what we've got here. Now you'll see some of the layer names. I want that to disappear, and I want that to disappear. So that's not in the way. Okay. You'll see some of my layer names change. So now mechanical one's actually called dimension, and I've got top chord yard, top assembly, top value, etc. So it pays to templatize things, and whenever you're importing footprints from somewhere, you can have it preset, right? And I think, again, most EDA tools have a way of doing this, either just using template files or through scripting, or in this case, it's just re-importing a file. But now I've got my proper 3D body layers, and they're done in pairs. So when the component flips to the other side, or if I flip a body while I'm editing the footprint, it goes to the correct layer and all of that. So yeah, so now I'm going to go to top 3D body, and import that step model of the module. Let's do that. Let's go place 3D body, and I put that also in the models folder. It's still here under footprints under SC0915. Okay, I haven't extracted it yet. Let's go back to Explorer and extract it. Still got a lot of sorting out to do here. Okay, so No, it's there in the footprints folder with a .step extension. So that should just come right in. There it is. I just wasn't looking for it. Okay. The orientation's probably wrong, so I'll have to figure that out. It could be right. In fact, it looks like it probably is. So let's just Control N, jump to the home there. And I'll hit 3 to give it a quick look in 3D. It actually looks like they oriented it perfectly. How about that? So that was pleasantly easy. There it is. So I've got my footprint done. Let's save that. And then that's got a proper 3D view now. And I've got my symbol. And I'll verify that those are correct later on. But that's basically it. I'll save that and then publish that into my cloud library. I won't bother leaving a comment. That's a bad habit not to comment, but I'll just get it done. Oh, I'm on the wrong screen to do that. There we go. Yes, stealing window focus. I agree. Stealing window focus drives me crazy. And you know what's even worse is when an application uses multiple processes and it'll launch a new window and the new window is modal. So it disables all keyboard and mouse interaction with the parent window. And the child process window is modal, but they haven't paid attention to window ordering, and sometimes it opens behind the other one. And so you can't see it, and you can't actually click on it or do anything. There have been numerous situations where Altium, other applications, even Fusion 360 has done that to me a few times. Even last night, it would open some dialogues, and I have a 4K monitor next to HD monitor, and the 4K, I was full screen, and a dialogue opened off the top edge of the 4K, and the code wasn't written such that it would force it down onto the other monitor next to it. It wasn't paying attention. It opened it off in a space that doesn't exist. So I'm like, now I have to randomly hit the keyboard shortcuts to see if I can find a close button and get it to close, because it locked up the whole thing while that modal dialog was open. Super irritating. Dave, am I willing to share my layer sets? Absolutely. I'm very happy to share my layer sets with you and anyone else who wants. I'll post them in the Discord, in the announcements channel, and I'll at you so that you're aware when I've done it. But yeah, organizations is one of the killers for me. I keep trying, and I'm so busy. It's the same trap. I feel like every designer has this difficulty. At least with Altium 365, I'm more organized with the designs once they're completed. But everything else, like I'm slowly working on it, trying to create a system for all the sources. So I have a components folder on my Dropbox. I've models folder in that. I have data sheets folder in that. And all of those things are broken out into a taxonomy that makes sense to me. And footprints are all broken out. 3D models are all broken out by JEDEC or other standards as well. Component outlines and things. And so I'm slowly getting there, but I feel like it's going to be a lifelong kind of deal. Okay, don't need that open anymore. So yeah, I mean, I'm already 5 minutes past the hour. So yeah, I hope that's interesting and helpful. And sorry, Bill had to jump off and put fires out with his network that he manages for the government. Unfortunately, that's prone to happen once in a blue moon with our stream, just because he has to be on call all the time. There's one parting thought I will leave you all with. Bill doesn't know I'm going to do this, so I hope I don't get in trouble with him. But really quickly, just want to show some concepts. He and I were trying to, for months and months and months, we've been trying to come up with things like logos and other graphics that are kind of our brand for this live stream. And I just wanted to throw out the seeds of some ideas I was playing with this week. Let me see if I can find them. Then okay, so I'll just open this up. There were some that were somewhat distant derivations. So watch this animation I made of two different swirling thingies that kind of represent the Coriolis effect of, different hemispheres, things spin in different directions, be it toilet water or a storm or but I kind of like this. This is derived from the idea that Bill had, and you can't see the last frame there. The player doesn't stop on the last frame. I wish it would. Let's play that again, and I'll see if I can pause it right at the end. So this is meant to evoke, the Coriolis effect, but we end right about, takes a while there. We end on that last frame. Okay. I don't like this player. I think I'm going to stop using it. The last frame ends where they're actually stationary but situated like an eye. And I liked that because to me it evokes an eye diagram, signal integrity and some of the things we talk about here on this show with the bodge wire and electronics and ringing. And one of the things that we look out for when we're doing signal integrity analysis is a good eye diagram. So I just wanted to throw that out there and see if you have any feedback on that. And I think it's cool. There were others that, as I mentioned, were somewhat derivative of the chicken head. I'll show you this really quick just because I like it. Bill expressed a concern that it wasn't respectful to the company he worked for in the past, and I get that. So I'm going to honor that. But the idea is we now have a CE for Coriolis effect, and the middle of the E is kind of like the end of a circuit board trace going to a via. So that was just another idea, but it's a little too similar to the chicken head for Bill's comfort, so we won't be using that one. But yeah, I mean, any feedback is welcome on any of those. But you can stay tuned. Hopefully I'll have a nice animation of a logo or something that we can use here and there. Okay. I think that's probably it for today. My voice is getting tired and I've got meetings to get to. Dave, you said you liked the first one with the eye diagram. That's going to be Bill's favorite too. He hasn't given me any feedback on it yet. I sent it to him last night, but I think he didn't have time to look at it yet. But yeah. Electron Ash, good point on the other one. It looks a bit like the Starship Enterprise Actually, yes. And that's probably another reason why we can't use it. We don't want to get in trouble. Though I thought they were fairly original ideas, but yeah. Okay. Well, thanks everyone for joining us. I know we're down to 26. We had 40 something during the main bulk of the stream. A few people probably left when Bill did, because I know you're really here to hear Bill's stories, and that's cool too. It's all good. But join us again next week. Not sure yet what we'll talk about. We'll probably have a guest. We do try to have guests at least every other week or every 3 weeks or so. And so who knows, we might reach out to one of you in the community to join us and show us what you're working on. So could be fun. And see you next time.